Welcome to tonight's webinar. We're going to give a few seconds for our attendees to join us. We have our numbers climbing up. I'm going to go ahead and get us started just for the sake of time. Good evening and welcome to the latest segment of the Water Matters series by SCV Water. Tonight we have gathered here for a webinar that dives into an important issue, navigating the Consumer Confidence Report and water quality concerns in the Santa Clarita Valley. As residents of the Santa Clarita Valley, we all share a common interest in maintaining and enhancing the quality of our water supply. The Consumer Confidence Report, also known as the CCR, is a vital tool that empowers us to make informed water usage and quality decisions. During this webinar, we will unravel the complexities of the CCR and address any concerns you may have about water quality in the Santa Clarita Valley. We have gathered a panel of experts with the wealth of knowledge and experience in water testing and management. They will shed a light on the report's significance, decipher its content, and provide valuable insights into the understanding and interpreting the data it presents. We understand that water quality concerns can be confusing and often spark apprehension, but rest assured this webinar aims to equip you with the necessary tools and information to navigate these concerns with confidence. We will explore the comprehensive measures undertaken by SCV Water staff to ensure the highest quality standards and discuss the latest testing methodologies employed and address any specific questions you may have. Furthermore, we encourage this to be an interactive session, and we believe your participation is pivotal in making this webinar truly an enriching experience. So feel free to engage with our panelists by asking questions, sharing your thoughts, and voicing any concerns about water quality in the Q&A box below. All questions will be answered after each speaker. And then Ryan, I'll have you move on to the next. Thank you. As the leading water agency in our region, SCV Water brings together a team of professionals who possess extensive knowledge and experience in water resource management, conservation practices, and water quality monitoring. Through the Water Matters series, we strive to bridge that gap between the community and the world of water management by sharing our expertise, engaging in open dialogue, and hosting informative webinars like tonight. We can empower residents like you to navigate the report and bring to our attention any concerns you may have. Tonight's speakers, one more slide over. Thank you. Tonight's speakers are Water System Supervisor Ryan Bai and Water Quality Laboratory Manager Jeff Colowine, and me, Laura Gallegos. And Jeff is our Water Quality Laboratory Manager. And me, I'm going to be your moderator, but you do see somebody else on, and his name is Kevin Strauss. He is our new communications manager. He will be helping me with Water Matters in the future. Welcome, Kevin. Now I will be handing it off to Ryan so we can begin tonight's presentation.
Hi, everybody. My name's Ryan Bai. I'm a water system supervisor here at SCV Water. I've been in the water industry for about 19 years. My group handles all the production of water, so distributing the water to customers. We do all the water quality monitoring for our system, and we tackle all the regulatory compliance associated with water and water quality. Before we talk about the Consumer Confidence Report, we kind of have to lay a groundwork, some foundation of what goes behind the Consumer Confidence Report. So let's talk first about water quality monitoring, and we'll go from there and build onto what the Consumer Confidence Report is. After that, we'll talk about some water quality calls that we often get and try to alleviate some concerns that customers might have. So how do we sample? We monitor. There's two parts to it. We have field instruments like this Hawk SL1000 here, where we can monitor for multiple constituents in the field. So that means going out and sampling in the field and getting real-time data back that allows us to make decisions pretty much instantaneously. The remaining of those samples go to a laboratory for analysis. I'll talk about that more a little bit later, and that will be a good segue to Jeff's talk. But the laboratory analysis, some of it is in-house that SCV Water's lab can do in-house, and some of it does go to a contracted laboratory. So where do we sample? We sample at multiple places within our system. One of the places that we sample, or one example of the places we sample, is our distribution system location. So this is in our residential areas. This is in our commercial areas. We have 111 of these locations that we monitor every single week. And they give us a good example of what is representative of water that is delivering to our customers. Some things that we look for when we're monitoring at these locations is nitrification, geophysical, and bacteriological, and that goes into our reporting too. Some of these samples we can do with the equipment that I had shown before, and some of it we do have to has to go to a laboratory for a process that Jeff will explain. Another place that we monitor for on a regular basis is our storage facilities. So we have 108 water storage facilities that we monitor at least once a week, if not more, depending on the water quality and what's going on in our distribution system. So here's some examples of our water storage facilities. And these little sample taps right here is actually where we pull the water from. Here's another example right here. And you might see these things on top of hills or at high points in our valley. But yeah, this is where we store our water, and it's a good place to capture some of that representative monitoring. Another place that we sample is our wells. So our wells are a big part of our source of supply for our customers. So a lot of the monitoring we do here is a little bit more, I guess we would say, arduous. So it does, most of this type of monitoring does go to an outside laboratory for analysis, and there are numerous different constituents we monitor for and on various schedules. Actively, we have 45 wells that we're monitoring for on a consistent basis, and each one of those wells almost has its own schedule for monitoring, and that is just based upon the water quality for that area and that type of a source of water. So talking about where we monitor, now we talk about some challenges that we've been faced with in this valley, and that does go into how we monitor and some of the information that goes into our consumer confidence report. One of these constituents is perchlorate. So this is a challenge that's we've been faced with in this valley. Perchlorate was used extensively in rocket fuel, munitions, and explosives. It can cause soil and groundwater contamination. The health concerns for perchlorate is it affects ability of the thyroid gland to uptake iodine. Currently, we do have ion exchange facilities that treat perchlorate in our distribution system, and we have more being constructed. So here is an example of what these ion exchange treatment facilities look like. They're passive systems where water flows through one vessel and into another vessel. They're in a lead lag configuration so that there is sort of a belt and suspenders aspect to water quality. So if you did have one vessel fail and it couldn't filter out perchlorate, you still have a backup vessel in place so that we can ensure good water quality. Our first perchlorate treatment facility is our Saugus perchlorate treatment facility. It treats 2 wells, and it was constructed and has been in place since 2010. Our next facility is just about to be brought online. It's our Q2 treatment facility. It has been loaded with filter media and is awaiting permitting with our regulatory agencies. And then we have a couple more on the near horizon, our V201 treatment facility and our V205 treatment facility. So this is all perchlorate treatment. The next challenge that we've been faced with and more recently is PFAS. These are per and polyfluoroalkyl substances. You might hear of these as forever chemicals. The first set of regulations for PFAS came in 2018, and that was regulated by our state regulators, the Division of Drinking Water, California Division of Drinking Water. Since then, there have been numerous iterations that DDW has changed with the regulations. They've added additional chemicals. They've lowered some of these maximum levels that can be in the water. And then coming up, there are some proposed federal EPA regulations coming soon. So that is still developing, and we're looking to see what that will entail. One good thing is that our agency has taken a real proactive approach to these regulations and treating these constituents. Initially, the monitoring that came out was only for 15 wells. Once we kind of understood the depth and breadth of what could be the contamination problem with PFAS, we went ahead and preemptively started monitoring all of our wells for PFAS. And from that data, we were able to quickly move into construction to construct and put into service the first ion exchange treatment for PFAS in California. We have currently 2 PFAS treatment facilities online, and we have many more that are in either planning, design, or construction. So just a little bit about PFAS. These are some chemicals that were added, and a lot of times we were firefighting foams and non-stick surfaces. And they worked really well because they did last for a long time, and they did a good job at repelling water. So they were in things like Scotch guarding and some paints. And more recently, they're discovering the health effects of these chemicals. And that's one of the challenges that we're being faced with. So much like the perchlorate treatment facilities, ion exchange is used for PFAS treatment. This upper left picture is that first ion exchange treatment facility in the state of California for PFAS. This is our N Wells treatment facility. It treats 3 wells, total combined production of 6,250 gallons per minute is the maximum treatment it can do. The bottom right-hand corner is our newest ion exchange treatment facility for our Valley Center well. It can treat up to 1,200 gallons per minute. And a cool little added bonus is our agency did receive an Aqua Award for this facility. If you want to think about in comparison, this is like receiving Best Picture as an Academy Award. This is a premier award that Aqua gives to innovative design and treatment. So that is something pretty cool that we just achieved. This facility was put online, I believe, in August of last year. And we have another treatment facility about to come online later on this year for ion exchange for PFAS. Now we've kind of set this groundwork, this foundation of regulatory compliance, of monitoring. Let's go into regulatory compliance and reporting. We do a lot of reports. All that monitoring that we do, it has outputs, and these outputs a lot of times are reports. Our main regulator is the Division of Drinking Water, California Division of Drinking Water. So we are required to provide monthly reports for things like bacteriological, genophysical, and nitrification constituents. And then quarterly, we provide reports for our disinfection residuals and our disinfection byproducts. And we have annual reports one of which is our electronic annual report. This encompasses pretty much everything that we do as a water agency, from water quality to billing to administration and safety. A lot of that goes into this report. So it's definitely all hands on deck type of report that we must submit. And we also do triennial reporting for things like lead and copper rule and a public health goal. So part of that reporting is the consumer confidence report. And this is a report that is due every year. It is to aid in transparency to our customers. This is a requirement by federal EPA. But even before Fed EPA had put this requirement out, California had a requirement for this report. It used to be called the annual water quality report. So if you ever see an old document that says annual water quality report, this is the predecessor to this consumer confidence report. So we make this available digitally, or if via hard copy if a customer requests it. It's circulated every year, and it encompasses everything that was done the prior year. So it's almost like an annual report to our customers. So when you see this 2023 consumer confidence report, this actually is our consumer confidence report on the right-hand side, the front page at least. It says 2023, but most of the data, all the data in there is from 2022. Reasoning behind that is it takes a while to get all the water quality results back for the year, to tabulate all that data, to make sure that we can circulate that to our customers. They start going in bills. Notices start going in bills in May and must be distributed by July 1st of every year. Previously, these were all hard copies that were mailed out, but in order to conserve on a lot of the paper, we've chose to do this electronically. But if there is a hard copy that customers do want, we can provide that. A lot of times the feedback we got was that this was mixed in with junk mail and people didn't even realize they had received it, and they would throw these out. So it was just a way to aid in reducing paper waste. We make a lot of media announcements about this. We try to reach every customer. We have notices that go out on our Instagram page. We do public notices. We try to let everybody know when this is available, and that there's a lot of good information in here. The contents that are required and that are in the consumer confidence report, there's a lot. And if you've looked at it, there's a lot of writing. There's a lot that goes into it. And our communications team has done a phenomenal job since we came together as one agency in trying to make that as user-friendly as possible and as appealing as possible for people to read. But there's still a lot of data in there. And sometimes that can be challenging. And that's why I'm glad that we're here and we're able to kind of talk about this. I'll give you a brief overview of some of the text that's in there, and then we'll kind of look at how to read the table of the consumer confidence report. So as far as text goes, we talk about the water sources that we use. So groundwater, surface water, recycled water, that's highlighted within our consumer confidence report. If we have any new sources that are brought online, we are required to do what's called a drinking water source assessment. And that looks at any potential contaminating activities that could impair our sources of water. So we can't just drill a well and just automatically just pump a new well into our system. There's a whole regulatory process that goes into place to making sure that it's a safe, reliable drinking water source for our customers. And so that's what that drinking water source assessment is. If we do have a new source that is brought online, that is put into our consumer confidence report. If not, then we pretty much just simply reference, if customers want a copy, we can provide that to them of the drinking water source assessment. There also has to be some information in there about board meetings and how our board meets. Our board is pretty much your voice of how you want this water agency to run. So your elected officials are here to hear from you and to represent you and what you want for this water agency. So there's information about this, our board meetings within there, and how to attend board meetings and when they're held and where they're held. There's also contact information in there. My name's in there because I do realize that it can be challenging sometimes to navigate this report. And so I'm always willing to talk to anybody and nerd out about water a little bit and kind of go through this consumer confidence report and any questions that people might have. I do my best to try to answer them. Some other content, anything with a primary drinking water standard. So primary drinking water standards are health standards, and they have what's called a maximum contaminant level associated with them. So this is the maximum amount that is safe to drink. So anything that has a MCL or a maximum contaminant level is data that is put into the consumer confidence report. One of these is examples of these are microbiological contaminants. So we report all of our total coliform monitoring. That's a type of microbiological monitoring that we do. We talk about in there treatment plant turbidity and treatment techniques within our treatment plant. That is a way for us to ensure that we are treating water to the highest standard. Some other content in there, our lead and copper monitoring we do. This is unique. Most of our monitoring, as I said before, is done within our distribution system, our tanks, and our sources of supply. And our lead and copper monitoring is monitoring that we actually do within consumers' homes. So there is special criteria that it has to meet, but we do provide bottles for customers to fill up, and we do monitor for lead and copper to see if there's any effect of our water on any fixtures that customers might have in their home. And then we have secondary drinking water standards that we put some of those in our consumer confidence report. Some things like sodium and hardness. Now, secondary drinking water standards aren't health related, they're aesthetically related. So anything that might affect the taste, the odor, the color, just how people perceive water, those are the constituents that make up secondary drinking water standards, and there are some of those included within the consumer confidence report. There's also unregulated contaminants. I've talked a lot about regulations, but there are up and coming chemicals that we do monitor for, and so there are some of those that are put into the consumer confidence report. And then there's a lot of boilerplate language. There's a lot of legalese, and this started off as a way to be transparent to customers, but some of those regulations of the language you have to put in there is not exactly how you would want to communicate with somebody. It's not written in plain English. It's language that must be included. So that's the part of the consumer confidence report that I do find challenging is, okay, there's a paragraph that we have to include. It's not written exactly how people would like to read it or receive it, I should say. So that's some of the stuff that I find a little bit hard. So here's another page from our consumer confidence report. You can see over here our general manager, Matt Stone. And before we all came together as SCV Water, our legacy agencies always work together on a consumer confidence report to put these out to our customers. And part of that, we also partnered with LA County Water Works District number 36, and they provide water to some portions of Castaic and the Valverde area. So we still partner with LA County Water Works District 36. So there's still some of their data in there, and they do have review of this and do include their information in there. On the right-hand side, it's a pretty cool graphic. I like it. Shows where our water comes from. So our water resources department kind of puts this portion together and talks about what makes up our water supply for the year. And that can change. That can change depending on drought. That can change depending on available sources. So there's a lot that goes into that. So that gives you an idea of what made up our water in 2022. And then here's another pretty cool page that I chose to include. This consumer confidence report is pretty big. These had the nicest graphics that I think would look better in a PowerPoint presentation, so that's why I included these ones. So over here, it kind of talks about planning for our future and what goes into our water resource planning. And there's some snippet on our PFAS testing that Jeff will talk more about. And to aid in transparency, also, there is a section on here about why you can trust the water that we are providing to customers. I know there is a general mistrust with our customers and the water that we provide. I just think that inherently goes with government agencies, and I don't blame anybody for asking questions and wanting to learn more. I am a customer. I am an SCV Water customer, so I do have making sure I do have a say, or I would say, I have a want and a need, I guess I should say, a want and a need for us to have the utmost clean and pristine water going into our system, and making sure that there are no health related effects associated with the water that we are providing. So this is an ominous table, and this is the hardest part for most people to navigate, because there is so much that goes into it. So this is where I'd like to at least try to help people navigate and see how you would look at this table. It is made up of the water quality monitoring that we did in 2022. And this is usually where I get most of the calls on what does this mean. So I was going to break it down a little bit and show some of the areas. The first thing is that we have our different legacy agencies that are listed in these columns here, and then District 36. So that's how this data is laid out. We are working to minimize this table, but that does require our regulators to view us as one whole agency, and that is in progress. So I'm hoping maybe next year or the year following, we can condense this table and make it a little bit more user friendly. So that's the first thing to look at, is we have our separate legacy agencies here. The second thing to understand is that a lot of these constituents, like all these inorganics, organics, right here, it's made up of the source water monitoring within that distribution, or within that system. So when I talked about monitoring at wells, that is what we're talking about. The fluoride, the arsenic, the aluminum, that is what's going into the system. It doesn't necessarily mean that that is what customers are receiving, because our water is a blend of groundwater and treated surface water. And so what you see here is for the Santa Clarita Water Division, the Valencia Water Division, the Newhall Water Division, all the different Newhall Water Divisions. That's all. At least the first portion here is monitoring at wells. And then over here on the left column, where it says Santa Clarita Valley Water Agency Import Division, that is information from our surface water treatment plants. So because our water is made up of groundwater and surface water and blended, I usually try to let people know that whatever constituent they're looking at, whether it's arsenic or fluoride or barium, or coming down here to these additional tests, calcium, magnesium, it's usually a blend of those two sources. And they are going to receive a blend of those two sources. So that's the second thing to look at. And the third thing is I see a 4.7 here, but what does that mean? Or I see like a 160 right here. What does that mean? That's where I refer people over to these columns here. This MCL column is about the maximum contaminant level. So this is the enforceable level of whatever constituent it is in the water. So anything above that is considered above a health standard that should be, of concern. Some of these have, and secondary standards, those are secondary MCLs, so those would be aesthetic related. But if it's an MCL, it's primary health concern, so it is health related. So that's what I would, next place I point people to is the context, right? So we have 100 of something in a water. What does that mean in context of how it relates to my health, and is it of a concern to me? And then the last thing, the last overarching thing I would let people know about is that there are these different constituents are broken down into subcategories. I mentioned already inorganics, organics, but we have secondary standards down here. We have some additional tests down here, and lead and copper monitoring also. So they are broken down into different areas. And I think that's pretty much it for this slide. If there are questions, we can try to answer on this table at the end. And if there's very specific questions, please feel free to contact me, and we can set up a time where we can talk over the phone to go through this. So now we're moving on to common water quality calls, and having been in the water industry for 19 years, I've heard a lot, and there's, you know, definitely some commonalities in some of the calls. The first one is, my water is hard. Does that mean it is unsafe? And unfortunately, the aesthetics of the water is usually how people judge the quality of water in terms of healthiness and maintaining health. But hard water, there aren't health concerns with it. Hardness is made up of calcium and magnesium. It's the same as some of the dietary supplements that we take. It's not a health concern, but it does cause some aesthetic concerns. So the spots on dishes, some of the deposits on faucets, maybe even some dry skin. Those are the things that are unfortunate about hard water. We do try to minimize this by blending our sources of supply. So our surface water generally has less hardness, and our groundwater does have more calcium and magnesium, which make up hardness. Most years we do try to blend these sources to minimize some of this hard water issues. But in times of drought, or in times where we have impaired sources, unfortunately, there isn't much that can be done as far as from a production standpoint, minimizing some of these hardness issues. There are some steps that customers can take on their own, but I'll leave that for another time, or for questions at the end. The next one is a seasonal problem that sometimes develops is, why is my water cloudy? So milky or white water, and I've experienced it too, and I can see how it can be alarming. You turn on your faucet, you go to fill up a cup, and it looks like either milk, or if you've ever painted and rinsed out a roller, that is what the water looks like. But it's not. Good news is it's not a health concern. What it is it's called entrained air. It's additional air that is caught up in water, and it stays in solution and cannot come out of solution until the water sits still. Because the water moving around in our distribution system is so dynamic, it doesn't have a chance to come out of solution, and it continues to look milky like this. So what I usually have people do is when they call me with this white water problem, is I'll have them fill up a glass, and I'll have them set it on their counter or put it in a refrigerator, and take a look at it. And usually within about 30 seconds to a minute, they'll see that it starts clearing up, and it usually starts clearing up from the bottom to the top. And if that is what they are experiencing, then the problem that they are experiencing is entrained air. And unfortunately, it does look like milky water, but it isn't a health concern. This can be caused sometimes when we have changes in seasons. So coming with colder water to warmer water, or warmer water to colder water, and that time sometimes that entrained air happens like that. Sometimes it comes from our wells. If our wells have been working for a long period of time, and we're trying to provide demand to our customers, sometimes it does happen. The next call that I commonly get is rotten egg odor in my water. So sometimes people will call and say my water smells like rotten eggs, or it smells like a match that was just blown out or struck. Most commonly, this is from sewer gases that have built up in the drain. This is a pretty cool graphic right here. It shows what happens when this thing called a P-trap, the water evaporates from it or is not able to sit within there. This water within the P-trap under our drains helps prevent sewer gases from coming up into our sinks. What happens sometimes is if that P-trap is compromised either through clog of hair or evaporated water in the summertime, those sewer gases do come up through the drain. And when people turn on their faucet, the water goes down the drain and pretty much activates those sewer gases, and people will smell a rotten egg odor and they'll think it's their water, but it's actually the sewer gases that are coming out from the drain. So what I usually ask customers to do is if they are experiencing it, to fill up a glass of water, step out of the room, because sometimes the whole room smells like it. Maybe go to another room and then smell the water. If the smell is dissipated, then we know it is the P-trap or sewer gases coming up from the drain. Next call we often get is, why is my water discolored? A lot of these calls we get are from during water softener canister change outs. So sometimes if those water softener bottles that are delivered, if they aren't flushed properly, when they are put online into customers' homes, it'll develop a yellowish tint to water, and that usually is a telltale sign of a water softener bottle that was just recently changed out but wasn't flushed properly. So that's usually the first place I'll ask my customers is like, do you have a water softener? Was it changed? When was it changed out? Sometimes they put tags on the water softener bottles. And if it is a problem with the water softener bottle, then they would contact the company to rectify the situation. Some other water quality discoloration might be from things like a hit hydrant or a sudden open and closing of a hydrant. So sometimes these unforeseen accidents, like a hit hydrant, will cause a disruption in the water flowing through the pipe, where large velocities of water will start flowing, and it will discolor the water. So hopefully that doesn't happen too often. We don't like hit hydrants, we don't like wasting water, and we don't like possibility of someone getting hurt. But it does happen from time to time. The last discoloration is sometimes customers will call with reddish colored water, and this will most oftenly be in customers with older homes that have galvanized plumbing that hasn't been repiped. Galvanized plumbing will tend to rust over time, the interior walls of the pipe. And if there is a large surge of water, maybe sprinklers coming on, turning off, washing machine turning on, turning off, it may cause some reddish water. But if this doesn't solve any of your water quality concerns, feel free to call us, and we have a water quality hotline that is available, and we can come out and investigate the problems that customers may have, or answer any questions, maybe eliminate a trip. Another common call is chlorine or chemical smell, and this differs per person. So we all have different abilities to smell and taste things. Some people are more prone to certain smells, and some people are not. Normally we use chlorine as a disinfectant, and that usually does not have a strong chlorine smell associated with it. However, sometimes we do need to switch to a different form of disinfectant called free chlorine, and that does have a stronger odor. And sometimes during that changeover period, it does develop odor issues. It's not something that we like to do. It's something that we try to minimize, but it might be something that is needed to safeguard our system and our water. And with that, I am pretty much done with my section of the presentation. So I am available for questions if there are any.
Okay, camera. Yes, we do have a question. What happens to PFAS or other contaminants that are removed from the water supply?
Yeah, that's a great question. So the media that we use is as proprietary media. It's ion exchange resin. So that is being removed. It is caught up in that resin. And when that resin is spent, it is disposed of and new resin is put into its place. So that is the process. Does that answer your question? I hope so.
Okay, I don't see any other questions coming up. We might just move on to Jeff's, but if you guys think of any questions, please just drop them into the chat as we think about them, and then we'll ask them at the very end.
Awesome.
Harold, I see that you have your hand raised. Please type your question into the Q&A chat box. I don't see your question coming in, Harold. But please go ahead and enter your questions into the box, and then we will answer them after Jeff's presentation. So Jeff, I'll have you come online.
I'm adjusting my camera. Am I all set? Looks like. Hang on.
All set, Jeff.
Thank you. I always want to make sure the technology is working. One thing I do like to do when I talk about some of the lab ideas is I have things I show the camera. So if you watch my video, occasionally I'll hold things up and you sort of can look at it on the camera. As Laura said, my name is Jeff Coolwine. I'm the laboratory manager for the laboratory here at Santa Clarita Valley Water Agency. I have worked in private and public laboratories for over 35 years. So most of the tests that I talk about, I've personally done. And in this presentation, I try to keep it, where you don't need to be a chemist to understand it. So I really try and point out, the whys, not get too much in the weeds of how these things work, and hopefully keep it interesting for everybody. So these are the topics I'll cover. Some basic analytical lab concepts. I'll talk about how California certifies laboratories, a little bit about laboratory staffing, who can do the testing, and then I'll review some of the microbiology and physical tests, and then some of the laboratory instrumentation. And Ryan's presentation is a good setup because a lot of the different constituents and water quality parameters he talked about all go into actually how we do those in the lab, just so you have a better understanding of what they are, how we measure them, and what they really mean. So when we test drinking water in a laboratory, we're actually part of a branch of chemistry called analytical chemistry. And analytical chemistry is the science of obtaining, processing, and communicating information about the composition and structure of matter. That's a very fancy definition. I like to break it down into two questions. One is the qualitative, which is what is it? And the second is quantitative, how much is there? Seems like pretty simple questions. One example I like to give about the what is it and how important it is, imagine you're walking down the street and a police officer is approaching you, and you have a little baggie like this of white powder, and you accidentally drop it on the street. All of a sudden, the question, what is it, is really important to you and maybe to the police officer. Because if your little baggie is some sugar for a neighbor, your day will be pretty calm. But if your baggie is some other substance for a drug dealer, your day will be dramatically different. So again, simple question, really important. Also with the quantitative, there's really kind of two extremes when we think about quantitative and testing things. One is the idea of how pure is something. So I have a picture of a gold bar there, and if you own a gold coin or a gold bar, it's important to you, how pure is it? Is it 99% gold, 99.99% gold? So purity is an important concept. And then kind of the other extreme demonstrated by those vials with different blue colors is a small amount of something. And of course, in drinking water, we're talking about things dissolved in the drinking water that we measure and have concerns about. And so we want to know how much is there. And as Ryan mentioned, then there are different levels that are considered a problem, hazardous to health, et cetera. So again, those are the two basic concepts that we deal with in lab testing. Now, chemists measure the amount in water in units of mass per volume. And you can start with a gram per liter. And then I have some common measurements that are used. And actually, these were all on the Consumer Confidence Report. The milligram per liter, the microgram per liter, the nanogram per liter, and picogram per liter. And I'll explain what these are. But since chemists use these metric units, you might not be really that familiar with them. So a penny weighs about 2.5 grams. But one thing I tried to do once was to visualize, how much is a milligram. So a milligram is 1/1000th of a gram. So I found a blue chemical and I measured out 1 milligram. So again, I'll hold this up to the camera and you probably can't even see it. There's like one little crystal and that's 1 milligram. And I also have one where I put 10 milligrams just so now you can see how much 10 milligrams is. So very small amounts, of course. And then a liter is about 1/4 of a gallon. So I have a 1 liter flask here. Again, I don't know if this shows up on the camera very well, but that's 1 liter. So if I were to dissolve this 1 milligram into the 1 liter, that would be 1 milligram per liter of that substance in the water. And then as you go down these different units, they're each 1,000 times smaller. So a microgram per liter, I would have to take 1/1000th of that 1 milligram and dissolve it in 1 liter to give me a microgram per liter. And then going to a nanogram per liter, that's another 1,000 times smaller. And a picogram per liter is another 1,000 times smaller. And these may seem like just really tiny, tiny units, but these are actual units used when we're talking about contaminants in drinking water. Now you also see I have parts per million and parts per billion. I'm going to explain that concept now. So the parts per million is usually where people start, but you can use it with a lot of different numbers. So I always like to start with, you have a nice box of donuts and you pick one that's different. Let's pick the chocolate frosted one. So it's perfectly valid to say that this box of donuts has 1 part of a chocolate frosted donut per 12 or per dozen. So 1 part per dozen. And that's what the parts per X concept is. It's just how many parts of something in a group of other parts. You could also even do this with parts per 100. So if you had 100 pennies and one was different, you could validly say you had 1 part per 100 penny, that was in those 100. That's also what we call a percent. So again, just it's how many parts in a group of parts. Now, we talk about parts per million. And again, these are more examples of what is one part in a million parts. So if you had 2,000 years of minutes, 1 minute in 2,000 years is 1 part per million. You can do it with money again. You can have 1 penny and $10,000 is 1 part per million. Or you can do it with length, 1 inch and 16 miles. And if you remember from the previous slide, a milligram per liter is equivalent to 1 part per million. And that's a pretty common level for a lot of constituents in drinking water, is a part per million. Things like chloride and sulfate, normal constituents in drinking water. So again, now if I take a part per million and go 1,000 times smaller, we get to a part per billion. So again, I took this table of these different items and I just did the math and reduced it by 1,000. So now if you talk about time, 1 second and 32 years is a part per billion. 1 penny and $10 million is a part per billion, so forth. And in drinking water, there are certain contaminants, and now usually these are non-desirable contaminants, can sometimes be in the part per billion range. We can keep going and do another 1,000 times smaller, a part per trillion, which is an even tinier amount. And the most common place we're using part per trillion right now are the PFAS compounds that Ryan mentioned. And I'll talk a little bit more about how we measure those. But again, this is an extremely tiny number, but we're actually measuring these contaminants in drinking water at part per trillion levels. And if you look on the consumer confidence report, the units actually reported would be nanogram per liter, because that's the actual proper term. The part per million, billion, trillion just is a way to kind of visualize how small these numbers are. So I talk about how laboratories are certified in California. And under the State Water Resources Board Division of Drinking Water, there is another department or program called the Environmental Laboratory Accreditation Program. Usually we call it ELAP. And when I talk about environmental labs, those are laboratories that measure those list of items, and really it's items from our environment. And it can be water samples, potable being drinking water, non-potable would be wastewaters. You analyze soils, hazardous waste. There's other items that have to be analyzed for regulatory purposes. And so if you're a lab and you're analyzing something for a regulation, you have to be certified by ELAP to do that test. Even our laboratory, even though we're owned by a public water agency, we have to be certified through ELAP. And so in a sense, we're an independent laboratory of the agency because we have to follow all of the requirements of this laboratory certification. And I list the steps there. Is if you have a laboratory and you want it to be ELAP certified, you have to apply to the state. Quality system requirements. There are new regulations that are very detailed of what a quality system is for a laboratory. Basically, this is a system that specifies all the different ways we do the testing and how we ensure that we have quality results. We do something on an annual basis called a proficiency test. These are unknown samples we purchase from a company. Let's do something simple like pH, so we buy this PT sample for pH, We don't know the answer, they do. So we analyze the sample, we report the result to this company, and then they tell us if we've passed, if we have the correct answer. And we have to do that for every test that we perform that we're certified for. We also have to have what's called an on-site assessment, or sometimes they call it an audit, where a outside expert comes in, interviews the staff, reviews all of our quality system, our paperwork, to ensure that we're doing everything correctly. Very detailed process. And then, of course, we pay annual fees. It is a state agency. Sometimes I call it the DMV for laboratories. And so when you've completed all of these steps, then you get a certification. If anyone ever wants to see ours, we have a document that shows all the tests that we're able to perform. And there are requirements for the staff that work in the lab. These are the requirements from ELAP, from the state. Basically, a staff person has to have a bachelor's degree in one of the sciences, like chemistry. It can also be biology, microbiology. There's a few others. And the laboratory director, who is the one managing the lab and the testing, must have at least 3 years of experience doing the lab testing. And then the state also has what they call requirements for the principal analysts. And those are the people that operate what they call sophisticated instruments. And they have a list of the sophisticated instrumentation, and this is their list. The red numbers, I put how many of these instruments we have in our lab. And I'll be going over what these instruments are, a little bit how they work. And so we'll just go through them one by one. And these are just some random pictures of the chemists here at Santa Clarita Valley. And you'll notice a lot of times we're in front of a computer because a lot of our data from the instruments is all on computers. We manage it with a special software so we can report it when we complete all the tests on a particular sample. So there are 5 of us, including myself, that work in this laboratory. So let's first talk about some of the microbiological contaminants that Ryan alluded to a bit. And of course, in drinking water, what we're mostly concerned about are pathogens, and those are organisms that actually cause disease. And in the microbiological pathogens, they can either be a bacteria, a virus, or a protozoa. You know, again, I'll talk more about coliforms, cholera, typhoid fever. These are all waterborne diseases. Viruses can also be in water. Protozoa are bigger microorganisms. Parasites, again, they can also cause diseases. And so all of these are something you do not want to have in your drinking water. The protozoa are a little bit, they're not common in public drinking water systems, but they are found in natural waters, even in the mountains. So people that hike the high country know they have to filter their water, even though it looks like it might be melted snow, very pristine. You can have Giardia or Cryptosporidium, and so you need to filter or disinfect that water before drinking it. Otherwise, you can get sick from it. And this graph is of the rate of typhoid fever deaths in the United States. And if you know any history of waterborne diseases that, you know, before 1900, many people would die from diseases from drinking water. And one of the biggest discoveries was that when you chlorinate the water, that kills the microorganisms. And this chart shows how when you begin to chlorinate all of your drinking water, your deaths really drop. So for the most part, if you're in a country that treats the drinking water, The other real important part of drinking water is keeping your wastewater separate, because most of these waterborne diseases come from sewage contaminating drinking water. And there are places in the world still, though, where that is a problem. And so you will read in the news sometimes about outbreaks of typhoid fever or cholera. Or sometimes if a country has a major earthquake that breaks down the system of treating wastewater and treating drinking water, you can still have outbreaks of these diseases. There are two tests that we mainly do that are called screening tests, because we don't have to test our water for all of these different kinds of microorganisms. We really break it down into looking for coliforms, and then there's a method called heterotrophic plate count, or HPC. The HPC test is just a screening test for bacteria. I think the next slide, has a picture. This is where we use a Petri dish. The picture there has some colonies. The camera, I'm showing you a clean disc. And it's basically, we add some water sample to this media. We let it see if anything grows. That picture you're looking at, I've never seen a drinking water look like that. That was probably from some type of food source or something. Usually the drinking water, you get almost none. So, but it is a useful screening, especially say you've had a well offline, or you're starting to put water through one of the media filters. The HPC can tell you if you've cleaned out your system and if you're ready to start using that water. Coliforms, there's actually probably hundreds of coliform bacteria. And this chart shows you that there's a different family. So if you consider this outer ring, the group of all of coliforms, not all of those cause disease, but we use them as a screening. Then there's a smaller subset of all coliforms that we call fecal coliforms. And those are the coliforms that are found in feces of mammals and humans. And then there's even a smaller subset of fecal coliforms called E. coliforms. And then those are the really bad ones. Those are the ones that cause disease. And you may be more familiar with E. coliforms in food poisoning. That's when you hear about a food poisoning outbreak, very often it's E. coliforms. And so obviously you don't want it in your drinking water either. So we test for coliforms using a test called ColAlert. And it's actually a pretty simple test. It tests, we start off, we take a sample, and I'm holding up a sample bottle to the camera. This is a sterile container that we fill up with water. And then we add a ColAlert media, which is a trade name. And we put it in this incubator, which is what you're seeing on the picture. The incubator is just a warming device. It's set at 35 Celsius, which happens to be about the temperature of our intestines, because guess what? That's where coliforms like to live. And so what we're trying to do with this test is see if our water grows any coliforms. Of course, the desire is that all of the testing is negative. We don't want them to grow, but this is a way we verify that. And what happens is, if there is coliforms that grow, we incubate them for 24 hours to see if they grow. And then if there's coliforms, the media will turn yellow. So the sample bottle will turn yellow. And then if we shine a UV light source at the bottle, if it glows blue, that's positive for E. coli. These are pictures just probably off the internet. Actually, I'll hold up again. This is normally what a negative sample looks like. It's usually water white. It doesn't look like anything. That picture there has a little yellow, but normally our negatives are totally clear. Recently, we were doing some training, and so we added coliforms to see how our sample would look, and it turns bright, bright yellow. So the sample I'm holding up to the camera, that's actual coliforms. That's a very yellow positive test. We do hundreds and hundreds of these tests a year. In the distribution system, maybe 1 or 2 a year are positive for the total coliforms. Again, that's a screening test. And often it's such a sensitive test. If we repeat the test, it's negative. We've never had a positive E. coli test in the distribution system, because again, that's the disease-causing test. If you ever hear of a water system putting out a boil order, that's when the public is notified to boil their water before drinking it. That happens when they have a positive test for E. coliforms. Because if you do have a positive E. coliforms, you don't want anybody drinking it. And boiling the water will kill all of the coliforms. But again, almost everything we do at our water agency in terms of treatment and distribution is all to prevent that from ever happening. And then some of the physical tests that Ryan mentioned, these again are really simple tests just to kind of show the quality of the water. One is a color test. This row of tubes just shows you how we have standards that have different yellow color. And again, virtually all of our distribution samples are like this tube on the left, totally clear. But if they do have color, we're able to assign a number value to them and know what kind of color we actually are seeing. Turbidity is actually another really important test, because when we treat our raw water, the turbidity is where the microorganisms usually are sticking to. And so part of the treatment plant process is to remove those particles, the cloudiness. And that removes a lot of the microorganisms. And the way we measure the turbidity is we shine a light source through the sample. And if there's any floating particles that will scatter the light, we can measure that and then get a number value for how turbid the sample is. So a perfectly clear water sample will have a 0 turbidity. And then if it has any cloudiness, we can assign a number to it. And this is the instrument that measures the turbidity. And the small vials in the front are all treatment plant samples that we've been measuring in that turbidimeter. Now I'm going to talk a bit about some of the more sophisticated instrumentation we use. Again, trying not to get too detailed. A lot of the techniques I'm going to talk about are using what's called chromatography. And the instrument is a chromatograph. And if you're familiar with the term chroma, it's same idea as a prism breaking light up into the colors. And that's what chromatography really is talking about, separating components of something. And so, for example, when we are analyzing ions in a water, what we want to do is pass the water through this column, and it separates the different constituents. And so that's where the chromatography comes from. And then we measure the output, and then these peaks that we get on our computer correspond to the different constituents passing through this column. And this is what the instrument looks like. And I'm going to hold up to the camera what the column looks like. And that's where the separation takes place. It's, let's see here, it's a plastic tube. Yeah, I know it's hard to see on the camera. And it's filled with a resin, which is actually similar to the resins in our treatment plants that Ryan mentioned. And actually, I have a sample of the resin beads that we use for perchlorate removal. But in our testing column, that resin separates the different constituents, and then we measure it on our system over here. And that's just the inside of the instrument, lots of plumbing going on. And then this is an example of the output. And so the bottom scale is time. So you see it goes from 0 to 20 minutes. The left scale is the output of the instrument. And this is actually measuring perchlorate in a sample. And when we do perchlorate testing, we want to separate out all the other dissolved ions in the water, chloride, sulfate, and that's what this big peak here is. But we've separated all that, and then we've got this peak here, and that's 10 parts per billion of perchlorate. And again, at the beginning, I mentioned we want to know what is it and how much is there. This time here where the perchlorate came out, that identifies it as perchlorate, because only perchlorate will come out at this time. And the size of this peak is the amount. So if this was a bigger peak, that would correspond to a bigger amount of perchlorate. And that also works for all of these instruments, where we identify, we separate, we identify, and then we quantitate. Another item that Ryan mentioned, hardness, is actually the sum of the calcium and magnesium. And the instrument we use to measure calcium and magnesium is called a spectrometer. I won't go over all of the details of that, but it's an ICP optical emission spectrometer. And what this instrument does is we create this really hot plasma. And basically, this is a microwave oven, and we heat up a flow of gas to really hot temperatures, surface of the sun type temperatures. And then we vaporize our water sample and have it pass up through this torch. And then what happens is that the different atoms in that sample give off color. Same idea as fireworks. All these colors in fireworks are from a different metal, usually copper, barium, strontium. Every chemical gives off a different color when it's heated real hot. And so when we're measuring for calcium and magnesium, there are specific colors that are given off. And so we measure the intensity at that wavelength, and we're able to then quantitate how much we have of that in the sample. And that's what the outside of the instrument looks like. You can see all of this down here is where we actually vaporize the water sample and then introduce it up into that torch. A similar type of instrument, but is more sensitive, is we still use the same plasma torch, but now we look at the actual mass spectra of the sample. And when I say the mass spectrometer, that's where we take these metal atoms and we put them into a vacuum chamber, and we can measure the mass. And an ICP instrument can measure most of these solid items on the periodic table down to part per billion levels. So it's an extremely sensitive instrument. Common things we test for with this instrument: lead, copper, arsenic, and actually many other metals that we check for. And again, without getting too detailed, the same idea is we have this torch that creates the ionized metal atoms. We separate them, and then we measure how much we have of each one to get a quantitative value for that metal. And that's what that instrument looks like. Again, the front is kind of similar in that this chamber here is where we take our water sample and turn it into a vapor. And then inside here is where the vacuum chamber is that measures the different metal atoms. There's another class of chemicals we look for, volatile organic chemicals. And these are things like from petroleum products, benzene and toluene. These are found in gasoline. There's different solvents that have been used over the decades. Trihalomethanes can form when you chlorinate water. And when we actually sample, because these are volatile, they tend to evaporate from the water very quickly. So we actually sample them in a special vial. Again, I'm holding this up to the camera. And this bottle has a special cap. And so we fill the bottle completely full of sample and then seal it so there's no headspace. Otherwise, all of our potential contaminants will be in the headspace and we won't measure them. And we analyze them using an instrument called a gas chromatography mass spectrometer. And again, we separate the different constituents. That's what the gas chromatography part does. And then we put them into a mass spectrometer. And now we actually look at the mass of the different molecules that we're looking at. And that's what this instrument looks like. And then last, how do you analyze per and polyfluoroalkyl substances, the PFAS that Ryan was talking about? Very difficult to measure these for two reasons. One is we're measuring at extremely low levels. Now we're again talking about the part per trillion. And then the other issue is that these molecules that we're looking for are actually very big and heavy, and so they're harder to separate. So this is the instrument we use to measure for the PFAS contaminants. It's a liquid chromatography with a tandem mass spectrometer. And again, liquid chromatography means that we're going to separate the PFAS compounds, and that's what this chromatogram is illustrating. Again, you have time at the bottom, 0 to 15 minutes, and then the intensity on the left. And then each of these peaks is a different PFAS compound. The other problem with the PFAS compounds, even though we have these separate peaks, they have very similar molecular structures. And so we also do what's called MS&S analysis. Normally you would look at the molecule, and that's what this diagram is of a PFAS molecule. That we actually break it into pieces and measure the amount of the pieces. And that's very unique for each PFAS molecule, only breaks apart in a specific way. So this way, this instrument allows us to very precisely measure what is it and how much is there. And that's it. So I guess now we will look for questions.
All right. So we do have some questions. This question is for Ryan. Do you use a water filter of some sort in your own home?
I do have a filter on my refrigerator, and that's because I don't really care for the chlorine taste and odor. But other than that, no. At times I do drink it straight from the tap, but to be a little bit more pleasant, it is the charcoal filters, the GAC filters in refrigerators to make it a little bit more pleasant. But yeah, that's pretty much it.
Okay. So there is no brochure that we're giving out that has the information. The information presented tonight was in the webinar. However, this is being recorded, and we will be posting it on our website, so you can always go back and watch tonight's presentation. And also the CCR is on our website as well. You can find the Consumer Confidence Report under water quality on our website. So hope that answered that question. There's a question regarding coliform. If non-acceptable levels are ever detected, then what is the procedure following detection?
Let me handle it, or would you like me to?
I could start.
Okay. Because that's usually how it starts, is Jeff will notify me if there's something that's bad that happens.
Yes, actually, there's very specific rules that if we ever have a positive coliform, we notify the person who took the sample. In our case, being an in-house lab, we notify Ryan or someone in his staff. And the regulation with coliforms is called the total coliform rule. And if only the coliform is positive, which is nearly always the case, as I mentioned, a positive E. coliform, I've never really seen happen. But the total coliform rule says if you have a positive sample, Within 24 hours, you resample that location, and then you also sample a location upstream and downstream of that sample point. So if the sample, say, was from a tap in a neighborhood, we have sample locations upstream and downstream along that pipe that we test. And again, nearly always the repeat sample in the upstream and downstream are negative, and that pretty much ends it. If you continue to have positives, you continue to do testing. The one place we do have more positives are what we call construction samples. And these are new pipelines that are not being used yet to serve water to the public. And because they've been newly installed, sometimes they have to be cleaned out. And there are actually specific rules that we fill the pipeline with chlorinated water. We let it set for 24, 48 hours, and then we analyze it. And sometimes those will come out positive because it might take a couple cycles of flushing and chlorinating to clean out this new pipe. But again, in actual distribution samples that are serving the public, out of hundreds, maybe thousands a year, we might get a couple positives. And also, a lot of times those positives will be contamination of the sample, especially if it's a rainy or windy day. It's a real challenge to do sampling in the rain and wind because it only takes a small particle of something to get in the bottle and it'll turn it positive. Anything you want to add, Ryan?
No, that's pretty much it. I mean, it does trigger what's called the groundwater rule too. So in addition to taking upstream and downstream locations and resampling the sample point, we're also sampling our sources of supply. So we're doing total coliform samples on the wells at the same time, anytime we get a positive. So it's an all-encompassing overview look of what could be a problem and helping us dive down and figure out what the problem is. Like Jeff said, most of the stuff comes back is absent afterwards. And it's usually just that it was just something that was contamination that happened while the sample is being collected.
All right, thank you. Thank you both for that. Okay, we have another question. It's sort of a statement and then a question. So we notice a lot of salt contamination, which makes it water hard. There is a whitish layer of scale formed on bathroom walls and floor and counters. How can it be prevented? Also, how is it safe to consume this much of salt and hardness in our body?
Okay, so most of, like what Jeff had said, most of the hardness that we're talking about is calcium and magnesium. And these are nutrients that our body needs. Whatever our body doesn't need is expelled. It's pretty much, it just passes through. It's different than the calcium and magnesium that we get through food sources. I'm not a doctor, so definitely check all of this out with your doctor and make sure that all this is true. But from my research and what I've read from World Health Association, or with World Health Organization, a division of drinking water, these are just minerals that our body needs. They are a nuisance, like you said. The scale does form on plumbing fixtures. There are some things that you could do, there are additives you can add to your dishwasher. One product that I use personally is a product called Lemmy Shine. You add that as an additive to your dishwasher, and that helps your dishes come out pretty much spotless. But it's just a challenge that we face in this valley. We are fortunate to have groundwater in this valley, whereas not everywhere has groundwater, or they have extremely impaired sources that they aren't able to treat. So we are very fortunate to have that water source, that we're not importing water from Northern California all the time.
Okay, somebody said, is it okay to use water softeners installed by Cliggan, which is widely used by neighbors around me?
Yeah, the only ones that were outlawed by the sanitation district were the self-regenerating units. Those are the ones where you add the salt to the tank. The Culligan ones, the other companies that are out there, those are fine to use. And it is a personal preference.
Right, I don't see any more questions in the chat.
I will say though, also with the water softeners, be careful if you do have copper fixtures. Water softeners and copper fixtures and copper piping don't mix well together. It creates an environment where you could start leaching that copper from the walls of the pipe. So you just be very careful with that, especially if you have older copper piping.
All right, and then also I did drop a link to our consumer confidence report for our attendees tonight, but that's always available on our website. So all right. I think that we are all set. Thank you, Ryan. Thank you, Jeff, for presenting tonight. To the audience, Jeff and Ryan are always pretty much available. We are a public agency, so if you ever want to reach out and ask questions, we are available to you. Thank you. And this will wrap up tonight's Water Matters webinar. If you have any questions, please email me. I will drop my email into the chat. But I'm also always available. It's just lgallegos@scvwa.org. So you can always reach out to me. Thank you to everybody. Have a great night and enjoy your first night of summer.
Good night. Thank you.
Thank you.